A mixture of weak acids. Here's a problem. Calculate the pH of a mixture of 2.00 molar formic acid and 1.50 molar hypobromous acid. And it says, what is the concentration of both the hypobromite ion and the hydroxide ion at equilibrium? So we're going to do the same steps that we did in our last problem. Our first step is going to be to list the major species in the solution. So we have water, formic acid, and hypobromous acid. So we'll write out those dissociations. We've got water, going to be in equilibrium with hydrogen ions and hydroxide ions. And we know our Kw is 1.00 times 10 to the minus 14. Our formic acid will dissociate into hydrogen ions and formate ions. And our Ka is 1.77 times 10 to the minus 4. And we've got our hypobromous acid, hydrogen ions and hypobromite ions, and our Ka is 2.06 times 10 to the minus 9. Now we want to choose the species that can produce the hydrogen ion concentration with the dominant concentration. So we look at our K values. The larger the K value, the farther the equilibrium is established towards the right, and the greater the concentration of hydrogen ions. So water is 10 to the minus 14, formic acid is 10 to the minus 4, hypobromous acid is 10 to the minus 9, so we're going to start with our formic acid. So we'll go through our problems, and we're going to write our equilibrium expression for our formic acid. So we've got Ka equals the concentration of our hydrogen ions times the concentration of our formate ions over the concentration of our formic acid. Next step is going to be to write our ice chart. So we have our formic acid, our hydrogen ions, and our formate ions. Our initial concentration for the formic acid is 2.00. Initially, there's no hydrogen ions and there's no formate ions. Our ionization is going to take place. It's a weak acid, so X amounts of our formic acid is going to ionize, producing X amount of hydrogen and X amount of formate ions. So at equilibrium, we're going to have 2.00 minus X for our formic acid, X for our hydrogen, and X for our formate. We'll take those equilibrium values and plug them into our Ka. So we have 1.77 times 10 to the minus 4 equals X squared over 2.00 minus X. Now again, we're looking at a weak acid, so our X value is insignificant. So we're going to get rid of that X out of our value and make the problem easier. Now we've got 1.77 times 10 to the minus 4 equals X squared over 2. We're going to multiply both sides by 2.00, take the square root of both sides, and we're going to get X equals 1.88 times 10 to the minus 2. And when we solve for x, that's going to be our concentration of hydrogen ions and the concentration of formate ions when equilibrium is established. Since we made x insignificant, we have to use our 5% rule to prove it. So we'll take 1.88 times 10 to the minus 2, divide it by the original concentration of 2.00, multiply it by 100, and we get 0.94%. That means that only a very small percentage of this 2.00 molar formic acid actually ionized, so X is insignificant. Now we've got other things that we need to solve for. We also need to solve for the hypobromate ion concentration, and we need to solve for the hydroxide ion concentration. So we'll do that up over here. So our Ka for the hypobromous acid is the concentration of hydrogen ions times the concentration of that hypobromite ion concentration over the concentration of our hypobromous acid. So for Ka, we're going to plug in 2.06 times 10 to the minus 9. And then let's think about the hydrogen ion concentration. When we look back at the Ka values for formic acid and hypobromous acid, it's 10 to the minus 4 and 10 to the minus 9. That means that almost all of the hydrogen ions in this particular mixture of weak acids comes from the formic acid. So much so that we're going to assume that all of the hydrogen ions comes from the formic acid. So we're going to plug in that 1.88 times 10 to the minus 2 for the formic acid, the hydrogen that comes from the formic acid, X for the hypobromite, and 1.50 for the hypobromous acid. And again, we are producing hydrogen ions from the water, and we're producing it from the formic acid, and we're producing it from the hypobromous acid. But based on the K values, almost all of it is coming from the formic acid. The hydrogen from the water and the hydrogen from the hypobromous acid are insignificant values. So we'll multiply both sides by 1.50, divide both sides by 1.88 times 10 to the minus 2, and we're going to get X equals 1.6 times 10 to the minus 7. And that's going to be the concentration for our hypobromite ion. Now we need to do the hydroxide ion. Well, we've got our Kw equals the concentration of hydrogen ions times the concentration of hydroxide ions. We know that Kw equals 1.00 times 10 to the minus 14. Again, our hydrogen ion is predominantly coming from the formic acid, so we'll plug in 1.88 times 10 to the minus 2 in for our hydrogen ion in this solution, and X for the hydroxide ion. We'll divide both sides by 1.88 times 10 to the minus 2, and that'll give us X equals 5.31 times 10 to the minus 13. And that's going to be our concentration of hydroxide ions in our mixture of weak acids. Now the last thing we need to do is calculate the pH. So the pH is going to be the negative log of our hydrogen ion concentration, which again is that 1.88 times 10 to the minus 2 value, and we're going to get a pH of 1.72. Now we always want to go back up and check the question at the end and make sure that we solved for everything. We wanted to calculate the pH. We did that. We wanted to calculate the concentration of the hypobromide ion. We did that. We want to calculate the concentration of the hydroxide ion, and we did that. So we've solved everything in this mixture of weak acids problem.